Hello, the stream should be going here in a mere moment. Hi. Bit out of breath. Real quick, I will be right back. I'm gonna go grab a drink. I have an intermission. Hello. Give me one moment. I will be right back. I'm gonna go grab myself something to drink for this chat because, well, I just realized I'm almost out of tea. I have returned with tea. There we go. Oh. So this is my massive engine testing platform, which I'm actually going to not use for the sake of this. I just had it out for the screenshots, to be blunt. Let's get a little platform going. Oh, I'm out of breath. Fucking hell. Oh, wow. There we go. I'm just trying to make sure YouTube didn't do the thing of like, last time I streamed, I never had any chats show up on my chat feed. Like, nowhere. Yay! Scrap Mechanic Survival Days. Fuck, those were awful. I'm not a fan of Scrap Mechanic Survival, like, at all. Let's grab engine. So what I want to do is essentially test. One of the things was forced induction. Someone in the Discord mentioned that they had worked with an engine designed to do basically supercharging. Yeah, I've seen some of the updates, and it's like, there was a lot of physics issues as well. Like, one of the big things I pointed out was that the the creative and survival mode had two different physics engines. I'm not sure if they fixed that, but for a while, if you built something in creative, you couldn't play with it in survival because it just didn't have the right physics. It has some wonky physics, like if you have items that collide with each other in improper ways, it's actually more buggy than Scrap Mechanic, because in Scrap Mechanic it would just jam and freak out, and this will actually go flying across the map at Mach 3. But when you actually like don't run into glitches, it's more stable. Where in Scrap Mechanic you kind of had to work with the glitches instead of avoid them. All right. So this is just essentially like the engine that I would put into a tank. With few slight changes, the power output would be on the other side. Let me grab. I was told one of the things was an air scoop or an air ram. Where's the? There it is. Or no, I didn't mean to delete that. Actually, I'm going to build it the right way around, just because I know it's going to frustrate me if I don't. Actually, I don't want to do this. Yeah. I'm fast. I'm just building an engine. It probably doesn't help that I've built this like exact engine like 3 times now. Frank, yes, tank. Fat fingered it. Just click it and select it. No, I don't pump air into my engines. So no, I'm not. I have not pumped air into my engines. That's what this test is all about. To see if it's more efficient or fills the function that I would normally use. Also, to answer Cody's question, yes, these would technically be considered 2 engines side by side, but because I'm using the clutches defaulted to a 1, I don't like these clutches for the normal engine, so I just use them as a linkage. So essentially both of these are connected. They are an H, if you were to want to say. They are an H pattern engine. They have their crankshafts connected mechanically. The reason I always drag stuff down is because if I need to swap between stuff, it's a little bit easier. I hate how you can place stuff through the menu. Yes, I know I have infinite electricity on. Alright. No, I need straight pipes. So I'm just going to use this as a power load. I'm actually going to use a clutch. And I'm going to use my tank drive. To run this. RPM. Fuel. There. I'll just do this clutch left. Active. On off. Button. Toggle button. Actually, no, I need a push button for this. Forgot the logic does the toggle. And we'll just set the WS to constant number 1. So as far as the vehicle is concerned, as long as this engine's concerned, it is being revved at full throttle at all times. Actually, may not be enough resistance here. Yeah, there's not enough resistance here. Let me gear this down. So this is what, this is a 10-cylinder engine right here. With everything in it compacted. Alright, engine's idling where it should. See what my fuel... my fuel is only taking 0.1 liters a second. And my air is only taking 0.2. This is at full throttle. This is wide open moving. Engine's not stalling, Blue. It's because this has a... So this design uses a clutch as essentially a CVT. So it changes the friction of the clutch to ensure the engine never... Because this clutch pressure is only at 0.4. Yeah. By default, most of my tanks, the tracks are actually over geared, I guess you could say, so that the clutch is responsible for the movement. So I'm gonna go ahead and save this real quick as just engine test flat Gila. This Gila monster update. And I'm also somewhat afraid that the supercharger is more intended for raw power output, but I don't use raw power output. I go for efficiency because efficient engine means smaller fuel tanks, means longer runtime. So fuel is not a concern in almost any of my vehicles, except for the Mark 26, the one I just made, because it's so tiny. There's like very little fuel on that thing. That's why there's fuel on the outside. A small pump for my area. Let's go and grab pump. Yeah, I'm just fucking it up. Oh well. How small? Let's load the... God, I gotta go back up. Here's the Mark 26. This is my full-sized MBT. These are proximity landmines. So let's grab a motor. Just for the curiosity of testing. And since we already have a constant number in here, let's just force this all in. They are a liability, but they have actually been lethal in a couple of contexts. No, my battles are not in first person. They're always in third person. Okay, so this is running at full throttle, pumping air. My game is froze. Oh, there we go. No, they don't help as ERA. They are not ERA. Yeah, in this game, explosives are more problem than good. I think I have this the wrong way around. No, this is the fluid in. Okay. Yeah, ERA would do more damage in this game than good. Come on. Is it because I'm not getting any air in. Oh, because I'm an idiot and I didn't hook up the throttle. That's where I... So this is literally, I don't know what this is doing. I'm getting air and I'm getting fuel in. I'm getting a -1 stoichiometric. The motor's for the turbo, yes. But it's still saying it's only pumping 0.1 liters. Real quick, just to make sure. I should have infinite electricity on. Yeah, I do, because the button's not connected. That's why. Well, so it should have been working there. I'm not sure why it wasn't working there, but it should have been working there. My test is more to just put the electric pumps. Electric pumps, the motor, the turbo. Yes, the motor for the turbo is on. I will be right back because someone needs me and no is not an answer. Big. Hey, I have returned. I apologize. So, part of me is assuming that the goal is to, because you need twice as much air as you do fuel, to basically cram more air into an engine. I don't think this is really going to work for what I need this for. Because for me at least, I'm using such a low amount of fuel and such a low amount of like everything. It just doesn't make sense for me to use. Maybe more power, but I need more power. I have more than enough power. This is a 10-cylinder engine. And that provides everything I need. Hello. It might be functional, but it's not practical. At least not in any of my applications. So the other test that someone wanted me to do was, can you convert exhaust into an air supply? So for that, I want to do this. Actually, fuck that. I can just straight up grab the air supply and bring it here. So I am going to use this for an outlet. Just to see real quick. I forgot to set up the logic for this. That would be helpful. Okay, this seems to be functional, but the air and exhaust might be occupying the same space. So what I want to do is a valve. And then this. So this way I can actually just shut it off and make it loop in on itself. Don't tell me the turn valve doesn't turn valve. Is there a different valve I need? Oh, the manual valve. Okay. So it needs air in to start. If I close. Now there's no new air coming into the system. The game just froze. And it's now starting to choke. And what I'm curious about here is less about infinite, more about, can I run an engine for a substantial amount of time underwater? Because it wouldn't be hard to set up a system where it's like, oh, if you go to below water, shut this valve and make the engine run off its own. Four miles or 4 meters? Four minutes. All right. What if we just do a tank system? We just have an air tank and an exhaust tank. How well would this work? Okay, let me make sure this is empty. Oh, default open. Fill level. Default open. And let's just have an exhaust tank here. Water empty. So if we start this up. I didn't hook up the... I always miss that. It's bad. Okay, 0.2 liters. So if I shut this... Can you have a container of air? Is that just a thing you can have? Wait. Would this be where a pump would be useful? I'm actually curious now, because you could pump air into this, in theory. In theory. Yeah, there's also one on WS, there's also one in the engine. Eh. Air doesn't transfer through the pump, it seems. I've selected the constant number. Please let me place it. There we go. Hello. Like, I'm not even trying to get pressurized air. Like, yeah, this tank contains 31 liters of air. So why can't the engine use that air? Okay, so the catalytic converters do convert exhaust to air because it's outputting some air. Quite a bit of air, actually. And when I did this, let's try the electric pump. Fluid pump. Okay, for some reason this works. So if this is defaulted to open, and then it closes, so there's no more air coming into the system. But it doesn't seem to be going down. Nothing's coming through, nothing's coming through. Am I using such little air? Okay, it seems to be stabilizing, so I'm guessing what was ever in the pump is now has now emptied. So it should be pulling from the tank. Hopefully. Okay, now it's ticking down. So if we do the same for exhaust, we see a lot of recycled air coming back. Like a lot of recycled air coming back. Now the engine's dying because the exhaust has been choked off. It's because what's mixing? No, currently there's no air feedback. It's just the exhaust and air are separated containers right now. So if we were to, for example, have air, tank, actually I'm going to put air down here. Mm. Let's actually do pipe. Oop. I'm going to say no to the old air filter. This is the new one. I'm trying to keep out like legacy components and stuff. So this is pumped full of air. Now there's no more air coming into the system. There shouldn't be. Well, I think it can flow in. So I think the exhaust only lets exhaust out. So this is letting the exhaust out. It should be. So if we do cut this off, now there is no... Oh, exhaust is building up in here. Let's see how long this runs for. I'm going to actually test one other thing, though. I want to make sure the exhaust can actually bring air in before we finalize this test. It can. Okay, so this won't really work for testing purposes. You could just submerge it. That should work. Let's save this test real quick. Let's head over to one of the water spawns. See. See if she can run underwater. Seawater has gotten in. Okay. Um, I'm pretty sure this only does like gas and stuff though. Allow gases, on, off, allow liquids. It's this way. There shouldn't be any seawater in the tank. We're trying to see if we can recycle the exhaust. How did seawater get in? Did the fucking air filter not? Did the air filter let it in? Does the air filter no longer actually filter air? Okay. Got a lot of stored... Why is air increasing? I'm kind of confused and concerned. Okay, the output just... Did the engine die? What's causing the engine to die? Got plenty of air. Did seawater get into the engine and seize it? I don't know how that mechanic works. Or did I place the filters on backwards? No, there's no in and out on these. Huh? There shouldn't be water getting in to the system. Not that I know of, no. Okay, there's nothing in the tank. Now there's stuff in the tank. It just sucked in a bunch of seawater. Do the filters have like a capacity or something? Confused what is actually going on here. It seems to be running normal. Apparently there's stored fluid going in and out of this. Okay. Nothing's coming out of here. Is the exhaust? Exhaust is working fine. Okay. This seems to be stable. Whatever exhaust should hopefully be escaping. In theory? I'm also frustrated that the air filter no longer works as an air filter, apparently. It just sucks in everything, including water. Is it still running strong? I kind of want to just leave this here for a bit and... Okay, I'm going to go back to... Actually, I'm just going to go up here to the railroad section where I can grab one of my tanks. I want to retrofit this onto a tank to see if I can just drive across the bottom. I don't want to do it to the tilt missile. I could do it to the Panzer G. This might actually be the best way to do it, because this one I don't think has a stupidly over-complex engine design. I'm gonna find where everything is, though. There's the air. Where did I put the exhaust? Oh, right there. Okay. So, I'm not going to use these fuel tanks. A set of fuel tanks can go away. So, this tank, empty. Pipes. Ooh, there's all tabbed out of the game. And an exhaust. Because apparently exhaust can bring in air as well. Oh, I need a filter. Filter for fluids and exhaust. Oh, I need to actually hook up the air intake to the drivetrain. Air. Okay. that immediately died. Good to know. So this should try and cram air into the system. Okay. Not sure what the difference between these two systems is. Maybe it's the location of the tank in the loop? Got plenty of air. Maybe the pressure given by the fluid pump is what was starving the exhaust? Okay, the exhaust is what failed here. See if we can get a more harmonious, I guess, balance between the two. And we'll add a small tank here just for the exhaust to be kept in. just as a bit of a buffer. Real quick. The amount of stored exhaust seems to be going up slowly. Let's see if we can do a valve. Pipe. So this way they are disconnected until we hit the water, and I'll press 6. And that will unblock the 2 so that now the engine will start recirculating. And I can easily set this up as an automated thing with some fluid sensors and stuff. Okay, real quick, just a test. The exhaust is slowly building up, but this isn't getting rammed full of air, so this should be stabilized. And I could probably even pump the exhaust out. And that's being filled full of air. And we go for dive, and 6. Sounds like the engine might be getting weaker. And there it goes, it just failed. The exhaust has been filled. So the issue is actually the exhaust getting out. Can I, like, force eject the exhaust using a pump? To, like, overcome the water pressure? I'm going to leave the valve closed. I'm just going to pump the exhaust out. Excuse me. A little bit of hiccup there. Frogman armor sounds like it. Okay, so right now I'm not recycling any air from the exhaust system. And I'm trying to pump the exhaust out. We are able to drive just a surprising distance off of the air tank system. But eventually it does stop. Still have got plenty of air, but no exhaust. So it doesn't seem like air is the issue in this equation. Which also means if you are doing some sort of like underwater amphibious, you may only need a single hose for the exhaust outlet to float or to get above the water instead of an air and exhaust. You can pretty much contain all the air you would ever need inside the tank for a drive. It's the exhaust that takes up the volume that needs to be expelled from the vehicle. Yes, yes it would be. My exhaust pump is backwards. Whoop, no. That's a lot of exhaust coming out. It just makes me feel like my catalytic converters aren't working now. But hopefully that level of like pressure, I'm curious if I could change like the percentage. Now it's just not exhausting at all. Hopefully that's not being built up in my system now. Oh, it is exhausting. Currently, this isn't closed loop. This just has a air tank and exhaust tank. I do have a way to close loop it, but yeah. I know catalytic converters aren't 100% efficient. That's why I have more than... Yeah. So I'd get like 10 times as much air as I do exhaust out of this system. Which means that, yes, exhaust will accumulate, but I shouldn't be underwater for lengths of time. Like, this is more than enough time to be underwater. Actually, here's a nice place for me to exit. And check. I'm not going to exit yet. I want to check on the system while it's underwater. So, we are slowly accumulating exhaust. Exhaust is not being pushed out this, so that's kind of pointless. Tank is still great on air. This does seem to be doing something, pumping the exhaust out, because I didn't see the exhaust flow a little bit ago. But instead of sucking through the catalytic converters, it might be better to press this through the catalytic converters. Like, just there. I accelerated and it dumped that out. Did that actually reduce my exhaust? Yes, it did. That did expel the exhaust. So, in this loop, my limiting factor is the air in this tank, which is very slowly ticking down, like... Which means I should be able to drive this underwater for a while with this sort of system. Let's go over to that island. See if we can make it to that island. So essentially what I need is a way to force air induction to a tank. It's not for efficiency's sake, it's solely for underwater travel in this situation. And the forced air induction is just so it gets basically pressurized. Also, I'm curious if my gun fires. Alright, there's the island. Yeah, I expect all this. And when the pressure update goes live, I hope we can actually have, like, pressurized air. Which would actually make the system possibly even better. And maybe even have a turbocharger, which would be nice. Well, that's kind of what I'm saying. It's just like, yeah, exploiting it for infinite power, a balanced turbocharger that actually functions within, you know, Newtonian physics and all that shit. Yeah, this wouldn't be a difficult way to do amphibious travel if you have like a sealed crew compartment so that water isn't an issue, or hell, a wetsuit. Or even just have this on one of the hydrofoil crafts. That way, if it does accidentally sink. And it's just like, yeah, the air in the tank is fixed. This is getting pressed. So let's take this back to hangar. And see if we can simplify this a little bit. So we don't need this loop connection anymore. That's kind of redundant. See if we can knock out one of these catalytic converters. And I still want to try the other pumps. I don't like the electric pumps because they're big, and if I can run these pumps off the actual engine, then I'd rather do that. Hopefully the engine should actually be driving this, but for now, I'm just going to put a motor. I should have a constant logic. There it is. And let's see if the air and exhaust filter actually work for their purposes here. I hope they do. I doubt it, though. Let's see if this fires up. Why are these pumps so trash? Ooh, where am I at? There, man. Yeah. What the fuck? Why are these so trash? Yeah, but they literally won't push gases. So torque instead of RPM, like an impeller should work. Okay, opposite. That makes sense. What I'm saying is they're counterintuitive because normally impellers work off speed, not torque. That's why they work so well as turbochargers. Okay, now they're functional. Yeah, the fluid pressure back into power, I've messed with that a bit. It's like, that, why? Why not? Why can't we have this? Alright, before I can make it to the island, I'm just gonna drive for the island and see how far I make it. Yeah, I've just lost power. Why have I lost power? I've got plenty of air, and for some reason there's fucking seawater getting in. The issue is my exhaust is completely stuffed up and this pump just can't handle it. Okay. Why are... I'm sorry, but I still am saying that impellers are just trash. Here, let's grab... I know I'm intaking seawater. They used to filter air, now they don't, which kind of stupid if it, eh. Um and yes, I'm aware I'm intaking seawater, but that doesn't seem to be the limiting factor here. However, I will strap a filter to this just in case. Well, if you didn't want it to filter air, then you should just use a normal, like, fluid inlet instead of an air filter. That was kind of the point of the air filter. Okay, let's see if this is storing exhaust. Yes, at an alarming rate. So let's see how badly we break the game. The old air filter was 1x2 as well. So if you wanted an air filter, you would just use the air filter, which was 1x2. If you wanted a fluid filter, you would just use the fluid port, which is a 1x2. Same size, different function. Air filter doesn't filter water. It used to. I got rid of that for some reason. Also, that's why I have a fluid filter next to the air filter. I'm still using the air filter for looks. Okay, am I building up exhaust still? Yes. I think it's because I have this on the wrong way. The fluid port doesn't require 3 that I recall. It requires 2. Hey, I'm not... Okay, it was the pump. I had the pump on wrong. Yeah, turkey. That's how the air filter originally was as well. It had a block in front of it that had to be spaced, then the filter, and then where the pipe connected. They were identical in size originally. It's only in the most recent update that they've like changed it so that the air filter is just a single block, and it lost its ability to air filter. Turkey, it's been ages since I've played this game, and my last tanks had the original air filter in their amphibious design so that when they would go below water or like waves would splash over them, they wouldn't immediately drown the engine. I use it as a major mechanic in a lot of my vehicles, and I hate that they've changed the air filter from an air filter. Which I guess honestly makes it more realistic, but at the same time it's just frustrating. Yeah, so this is the Panzer of the Lake. Okay, I've lost power. Why have I lost power? Is this full up? Why is this not spinning? Do this whole joke. The thousands of... Oh, I think my game just crashed. Oh, no. Game. Hey, my game didn't crash. Yay. The goal of this testing, Berlin, is to make a tank that can survive underwater for a set amount of time, essentially. Because I really do like amphibious tanks, and actually making a tank that can traverse underwater safely. Because originally the amphibious tanks I built were big, bulky, meant to float. Then I went to a hydrofoil system, which worked well, but in a lot of situations, if the hydrofoil failed, you were screwed. This is a kind of medium between the two, that I could still use the hydrofoil system on this tank in its current design, but if the hydrofoil did fail for any reason, it wouldn't mean I was dead in the water. It would mean I'd have a few minutes of runtime underwater. I've worked with snorkel setups, and the thing is, a lot of the water and canals are stupid deep. So to actually traverse a canal, you need a really tall snorkel. Or if you use a hose, you need a proper flotation device. So, but this system, I could actually adapt a snorkel if need be. But seems like I might be able to pump out the exhaust faster than it can accumulate by... not now. This isn't working now. Which means here in a second that exhaust is going to build up. Here. I'm going to do something. T. let's go ahead and actually like make this somewhat reasonable. Say just 1 gear. And let's do a dial. Dial. This one I think was 31. This one was like 180, I think. 31 times 3, or no, 31 times 6. Okay, the air tank immediately fills, which is really nice. And I'm going to do some just like land driving to see if the exhaust starts to fill. So right now it's expelling like it should. It doesn't seem to be filling. God darn it. So this is just an air tank design. But what I'm doing is, okay, there the impeller just started kicking out a bunch of the exhaust, and now, since it's left, in this sort of situation, I could essentially stay under as long as I have fluid, or as long as I have air in my tank. Now, this is the sort of scenario where I would actually, like, yeah, I could do a snorkel. If I did a snorkel in this design, I could stay underwater indefinitely. Because, like, look at the other needle. That's my air tank right now. My air tank is barely budged. I just need enough tank to, like, hold some of the exhaust until the impeller can expel it. Because here, it should hopefully provide enough pressure. Yeah, that's a problem. Is it because of the depth I'm at that it needs more pressure to pump out? Yeah, because my tank's about to fill. It's not pumping the exhaust. If that hits all the way to the top, it's going to starve the engine of exhaust, and we're going to be in a hell of an issue right now. And there we go. I just lost engine power. Oh, not quite. Still got a little roll on the tracks, looks like. Oh, now it's starting to expel exhaust? Oh, it did appear to be external pressure related. Okay. And we'd always said like that there's a minimum RPS for the propeller or the impeller to work. The impeller's working right now because it's expelling exhaust. If you're using a clutch-based system, having slop in your clutch can cause it. You need to... So tracks like positive power. If they can roll on their own, they can drift. They're a little wonky with that. And the issue I had before with like the vehicle, the Mark 24 turning against my will was an issue with the armor causing physical glitches to happen. That may be a issue with your like your subframe, your subdivisions, colliding or contacting in a way they weren't intended to. Yeah, turret and hull interacting. Yeah, track tension can fix some of the issues, and sometimes so can the actual grip strength. Stormworks, for some reason, doesn't like 100% grip strength. You can actually see it with the grip pads. If you put a grip pad on the ground at 100 strength, like by itself, it'll just start vibrating. Which is funny. But I don't think it's an intentional game mechanic. Still find it funny, though. Track tension essentially gives the wheels a level of springiness. It's similar to the wheels air pressure slider. So the lower the track tension is on a wheel, the more like give it has, the more bounce it has, I guess. Okay. So underwater exhaust pump does not seem to be the option. The electric one works the best, but that's still kind of um if you have it at 0, it'll be like a flat tire. Real quick, I will be right back, and I will get back on this. I want to try a little bit more with the pump setup, but I will probably mess with a snorkel concept. I have returned. Oh, wow. Sewer run flat. So running this pump. I want to see if we can run it like completely underwater. That's the end goal in all of this. To have the pump have enough pressure to expel all the exhausts underwater. Currently being driven by the engine doesn't seem to be the answer here. Because I could try different gear ratios and stuff, but it just seems that the exhaust is too overwhelming. The electric ones seem to work okay. Actually, a little bit more than okay, in my opinion. So I'm going to go back to the electric system that I had a second ago. With this, and then the motor. To here. The big electric pumps do actually have more force than the small ones. The small electric pumps are the small impellers. So I only saw one electric pump to my knowledge. Oh yeah, there's the big electric pumps. There's the the huge ones, the like 2x6 or 2x2x3, I think it is. Alright. I'm gonna get rid of this pump. I'm gonna go to the electric pump to test it. And then I'll go to the large electric if I need to. Same speed, but significantly stronger power. Okay. Oh, I forgot to put active on this. Okay. That needs to go there. It seems in this situation, force is what we actually need. Now, this is an infinite electricity system, so if the pump actually just takes so much electric, it may not be viable. Okay, but this isn't... Okay, it is starting to increase. But before, it would get a little bit higher, like 2 of those bars, and then it would expel a bunch of exhaust back down to 0. Like that. There it goes. And it just let off another exhaust. That's what I want to see. Is that there? Now here's what I'm kind of curious about. Since I already have this pump in place, this engine in particular, I'm just gonna put this motor here. That should be... Just do this. That should be enough to actually suck in air on this. There. What I want to try and do is move this tank. And we're going to swap it for a small one, which is, what, 31? So let's put tank here. So small tank, just enough to take some of the back pressure. Then pump. And from here, here's where I want to put the catalytic converters, because I've noticed in my own testing that the catalytic converters do like to be separate exhausts rather than going back to single pipe like they were there. So if I have the fluid here, see if this works. And see if this produces a bunch of smoke. I forgot to put the active. I always forget that. There we go. Oh, and I didn't hook up the logic for tank container. And I forgot to set this to 0. Okay. So this is a lot more compact system and is pretty much just like 2 extra components to what my normal would be. So I want to see how well this works. Okay, exhaust doesn't seem to be building. I'm not getting any smoke, which is nice. Go underwater. Okay, exhaust is starting to build into the tank. Let's see if it gets expelled. Okay, I'm just going to stop the engine, see if the pump can push it out. Or if the engine's going to die. I think the engine's going to die. Or if the engine goes into low power mode, that's not awful either. As long as it just doesn't die outright. However, I feel here in a second, it's going to just be like, yep, can't take it. It's going to just go put, put, put and die. Yep, there it goes. Alright, let's see if we can... I wonder if it's the catalytic converters not letting enough exhaust out in this situation. Okay, and suddenly it's starting to fill really fucking quickly. Is it because of the pressure difference? If I back up and go... Nope, engine's full. And engine just died. Hmm. Guess I can do this as a pipe. Just watching that dial, waiting for it to skyrocket. Maybe it's a thing with, like, the catalytic converters getting wet. I may have to put, like, a filter on the end of them or something. Because with the other design, the pump was, like, the last thing in contact, so the pump would, of course, keep the water out. But in this scenario, maybe water is getting in and clogging the exhaust. Even the catalytic converters have an in and out direction, so that shouldn't be part of it. Okay, this electric pump is way more powerful. I hope it's not like a major electric draw, though. Curious how much power it's going to consume. This is working. This is working actually well. True, but it's also possible that I just run this, like, either not at max power, because right now it's just set at max power. Hi, Vapor. Or possibly set this up so that it only turns on when underwater. That is an option as well, I believe. But in that sort of scenario, you also wonder how much size this might take up if you actually do apply it into a tank. Why is the tank underwater? Because we're testing exhaust and forced air induction. This is using an air tank to run the engine, and is using a pressurized exhaust to expel it into the open ocean. And in this sort of setup, I'm not even sure if we need an exhaust storage tank because of just how quickly this is expelling. Oh. So to get to this island, we used about half of our air. Which is slowly trying to fill back up. Because there's water in the system, I wonder? Or it might just be because impellers are shit. Could I just use a fluid port instead of an air intake for that then? So 2 tests I want to do. One, can I go back to my old catalytic converter? I want the catalytic converters to mask the exhaust smoke. That's what the cats are for. The cats are in all of my tanks, just for, like, disguising the smoke and reducing signature, and also so I can see. Because the smoke kind of expels right in front of my screens. Okay, so driving around a little bit. Also, while I'm here, is this thing still running? Nope. Okay. I know I kind of left it there to test, and I didn't expect it to be. I want to basically bleed off a bunch of the air that I have stored, driving around, and see how quickly it fills up with the fluid port instead of the air intake. Because that's one of the reasons I love the air intake, because you didn't need one of these fucking bleed systems. Yeah, I know. Just out of curiosity, because I wasn't sure if the air intake could actually output if it only drew in. So this one, the air system needs a bleed. So in this case, wouldn't it be better to have the pump on one side of this with a filter, a intake, this. Nope, that's not what I wanted. I wanted this. So this one will take in any gases, this one will take out any liquids. I hate this impeller. This impeller sucks. I want to just drive it across the coast until the air tank starts to deplete. We'll drive it out and see if it replenishes properly. I do like the way the bullet bubbles through the water. This is staying pretty well. Interesting. Like, I understand my oh, there it goes. It's starting to tick down now. Like, I understand my engines are pretty, like, air and fuel efficient. That's kind of the point of them, but... Ow. Like, we driven all the way around this. Yeah, we driven all the way around this coast. The canal should not be an issue. There's a lighthouse. Okay, once we get to that second bar, I'll drive out of the water and see how quickly it fills. Hopefully it should be, like, near instantaneous. Alright, and out we go. And there we go, full air tank. That is a single small air tank. And an extra fluid pump modification. Like, yeah, there's a little bit here when it comes to this setup. I'm actually tempted just to run off of run off the engine if I can, because the gear ratios and all that fun stuff when it comes to the electric engine. Alright, let's do one real quick test to, whoa, run the impeller off the engine, see how well that works. Because we only need a little bit of pressure from this side, we need more from the exhaust side. So, actually, you know what? Let's test without a gear first. Without a gear. Let's see if the engine can run off this as an air intake. Alright. That looks promising. Air scoop, because it makes your vehicle... Speed is not really concerned with my tanks. They're pretty fast. The issue for me is always efficiency. Not impede other pumps in line with it. But it was impeding the flow of air with the electric engine. No, when I had an electric engine hooked up to the impeller pump, it was actually starving the engine of air. It couldn't suck air through the pump. It was. Yeah, it was Turkey. The electric engine directly to the pump just didn't have enough power. Hello, Connor. So I'm going to respawn this once more. I'm going to save this real quick. Panzer of the Lake. Yes, for the joke. And actually, let's take it to this airbase, because I want to like do a channel crossing it, an amphibious maneuver. And another thing is, like, I may just add this to hydrofoil craft that I have, so that if the hydrofoils do fail, I can still resurface, essentially. Connor's asking, how is the air getting to the engine? So, here's what's going on right now. There's two separate systems in place. One is the air system. So, air comes in port, gets pressurized slightly by a pump, and it goes through a channel. If it's air, it goes in here. If it's fluid, it goes out here. This is just to clear it when we're underwater. Air is stored in this tank, and while we're underwater, we have no air coming in, but the engine can pull from this tank. And the exhaust comes out. There's a storage tank, which we may not need. And actually, for the sake of this test, I will remove that tank, because the pump should be able to supply everything. And pump takes the exhaust out, throws it through some catalytic converters, and it comes out pretty clean. So as you can see there, that dial just went up. That is the air tank filling. And the other one, which is actually no longer connected because we just disconnected the exhaust. I don't want to be so slow. Just gonna boost this tank's speed a little bit. It's weird it wasn't working for me then. Maybe it's because I have the tank on it? Actually, this is one where probably having the gearbox on the impeller would be better for efficiency. I'm gonna do that. Yes, I keep saying I'm gonna go throw this into water and test it, but curiosity killed the cat. Oh yeah, it's more than powerful enough to power the impeller. There we go. Now we're a little bit faster because now the pump isn't stealing as much as the engine's power. This impeller pump just basically needs to fill an air tank. It doesn't need much strength. It just needs a little suction. It's the exhaust that needs the power to be pushed out while we're underwater. Does the bullet actually fire? I don't see where it goes. Oh well. So yeah, we haven't even like touched our air reserve and we've already crossed this literal lake. Like 0.02 liters per second. This is a single small air tank. I work heavily with like highly efficient engines. I'm only using like 0.1 liters of fuel at full throttle. And at idle, it's only like 0.0001 or something liters per second. And this is a, what, 10-cylinder engine? I love that YouTube's comment thing puts an icon over the comments. I wish I could actually AFR. What are you controlling AFR or stoic at 0.2? Where are you controlling AFR or stoic? So for me, all my engines just basically go, okay, here's how much air I'm drawing. I use half the fuel. Fuel is always half of air for my engines. and I use a clutch as a CVT transmission to keep the engine at its optimal, like... I choose an RPM range. The higher the RPM, the faster the engine, but also the higher RPM, usually I have to have a more powerful engine for that, a larger engine. So 10 RPMs is almost always my goal. My system works. It's also really efficient. I've also just crossed a lake. Like, I was testing forced air induction. It seems to possibly work, but for the application that I'm using it in, it's kind of pointless. I don't need higher power engines. I need more efficient engines. Small engine that's faster isn't as useful to me as a big engine that's more efficient. Because quite literally with nothing but a clutch, there is no gears in this, there's no gear switching. I should be able to just, well, other than the track neutral steer, I should be able to just push against this and just, oh, I slipped off the thing. Let's see, come on, actually like touch into the, there we go, yeah. So here's the thing also, Turkey, I am using a forced air induction at this point. I am full throttle right now. That's also the thing, is like, I'm not half throttling my engine. My air intake's full open and it's only taking like 0.1 liters of air at full throttle. Can I climb this? No, my tracks won't hit it. But, Turkey, what I'm saying is I can't get the air intake to go over 0.01. Doesn't care what the fuel intake is right now, because the air intake is locked at 0.01. So I'm using a low RPM engine that runs at, this one runs right now is running at 10 RPM, which I think is actually, it's faster backwards, I believe, because of the way I have the gears set up by accident. What kind of cylinder count do you run? 10 RPS, yeah. What kind of cylinder count do you run in your engine then, Turkey? Okay. So I'm going to take this back. I'm going to save it. And I want to do some more testing with the forced induction systems. So let's load this test we did a second ago. So this is just a test bed engine. Exhaust is just going to stay normal. And what you're suggesting is, I'm gonna use this just for this test real quick. To say, here is the most air that I can slam into an engine. See what the stoichiometric values go to. And instead of using the normal divide by logic, I'm going to do a throttle. So that way we can vary. Let's grab 1, divide by, and then we're just going to use 1 air, and then this will go to fuel. Max value 1, sensitivity we're just going to do 25. So if I start this up, it'll be a 1-to-1 ratio right now. Yes, now you're feeding it so much air it can't even run because you're giving it too little fuel. You need to tell a fuel inlet to be above 0.5 if you start using heavy forced induction. That's why I use ECU. ECU, can you please explain instead of giving me an acronym that I don't know? Over divide by, sure, the divide by works, but it likely won't be able to slap on an air scoop without having to redo all the math. Okay. Let's try this then. Let's try full that and less air. Okay. Hmm. Are you using sensors to determine the air and fuel flows? Or is it just like based off the numbers you're putting in or the throttle level? Composite and temperature. Air volume, fuel volume, temperature. Okay. I didn't know cylinders had a composite, by the way. That's new information to me. So essentially you want a 13.9 to 1 air to fuel ratio. So for this, I can add a, let's add a, ooh, not what I want to do, logic. Add a composite input. Oh, I probably spelled that wrong and I don't care. Cylinder. Close enough. So if I read the cylinder, and let's see. $14.7 to 1 is what Google says should be the perfect mixture of air to fuel. For every gram of fuel, 14.7 grams of air required. So if I grab a composite read, channel 2, so real quick, the cylinder gives me air and fuel. All right. Yeah. I don't care about the gen RPM in this one. Shouldn't even have the gen RPM as a thing in this one. So essentially what's going to happen is I get the power equation, the overall throttle. And for this, the power should go to the fuel, correct? And then air would be I'm going to use a PID just because they're simple. And they're just kind of easy to fit into places. Proportional gain, just say 1 for now. Whenever the on-off is toggled, this will be active. And the goal is to set... We're going to say the air is what's going to be set. Because we're just going to set a solid fuel. And we're not going to divide by, we're just going to leave this at 1. So that the air will be the thing that's changed. So air is the processed variable, should be 13.5 times the fuel. I'm going to say 13.9 x. Just because I want to cause chaos. I told you to go for air to fuel ratio, but you can't go to an air to fuel ratio. I'm going to divide this by... I'm still going to divide this by 2. I'm just going to say that fuel is set at a certain limit. For now, for the testing. This is even going past the value I've set. Because even in this one, the fucking stoic is always going to 12. Oh, did I? I'm an idiot, I think. Yeah, I still have them hooked up to... Still have them hooked up to the fucking throttles. Okay, let's go back to 13.9 then. Yeah, I did a dumb. Because I can. Because I'm not taking your word for law, James, that's why. Because I'm doing testing. Why is this taking so goddamn long to actually, like... Yes, I realize my air to fuel ratio is at 2.2, but it shouldn't be. That's why I'm like, why is this not working? Yeah, to be blunt, I don't see a use case for forced induction. While it could be useful in some situations, it's not seeming to be useful in many. Because it's like, if you're set for a set RPM, just go for that RPM. You're adding a level of complexity that's really fucking annoying. And instead of being able to use just normal calculations for stoichiometry, you're having to boost your power so much. More powerful engines, smaller. People are saying it's so amazing. Well, it's not working. So far it's not very good. Air is going to be 13.9 times the fuel volume, which PID RPM. System is not working. I told it to aim for 13.9 and it's aiming for 2. Okay, this is being powered. A little light. No, we kind of figured out breathing underwater. Well, using a small air tank to run underwater. Now we're going back to forced air induction to see if it actually does have an application. So far, it's just, for me, adding an unnecessary amount of complexity. I've never set a PID to 400 before. This is a new one. So far, I think what's going on is there is a max flow to this manifold. That's what I'm running into. So if I were to just set this to 0.8, just for the sake of testing. This PID just straight up is not working. Like, at all. It is active, but it's non-functional. I don't know what's going on with this PID. Like, it's nowhere near the value I told it to hit, and it's just giving up, and it's not inputting anything anymore. And instead of, like, 1, which is I have it set it to, it's only doing, like, 0.00000001. Why the fuck is this throttle not going up? You should just divide the air throttle by a variable on the other throttle. That's what I had before, Connor, but I was told that wouldn't work here, so I stopped using it in terms for a PID. Throttle is the air and control the fuel. Okay. So this one's going to go to 1. Because we're going to move the air back over here so that we can move the fuel down. We're going to connect the fuel to the PID. Get rid of this so it's just a direct connection. I'm not going to worry about this. This can stay there. So now this is the set point. Let's use a divide by function instead. So air divided by 13 point is the new set point. All right, let's try this then. So now the air is full throttle and the fuel is what's being controlled here. That's what I was using before, Connor. And like I said before, that's what I was told wouldn't work, so I've swapped to something else. So I'm going to go back to the old system I was using. You say 1.5. Let's see how this will work. Saber, I've said this multiple times to multiple people. I doubt it. I'm open to seeing what it looks like, but with how bad Scrap Mechanic has been, I don't have high hopes. Donut jet engines? Not that I know of. Hmm. Connor, this is literally what you just told me to do a few minutes ago, and you're telling me not to do it. That's why I was trying the other system out. That's why I was trying to use a PID controlled system to automatically fluctuate the air to fuel ratio, but it won't set a good output to throttle. Throttle should be a variable that hovers around 1.5. For fuel or for air? Okay. So my air throttle will just be 1. This can go away. This can go away. So this is just my controller. While idle, it fluctuates the air. When I'm driving, it sets air to 1. This is a sensor that detects the cylinder that says, here's how much air, here's how much fuel. The fuel should be a 13.9, which is what this was earlier used for. 13.9. So the fuel should be 13.9 of whatever the air volume is. I'm reading the air and I'm reading the fuel. I'm checking how much air is in it, and I'm trying to match that with the fuel. So are you saying I should be doing air divided by fuel and then PIDing that? Okay, so air to fuel ratio. You need 1 volume of air, or no, you need 14.7 volumes of air for every volume of fuel. So I'm detecting the volume of air and the volume of fuel, and I'm PIDing it to try and fluctuate the fuel volume to be 13.9 or 13.9 of air. Connor, yes, I know. That's why I'm getting bounced back and forth. 13.9 is my variable, and that's my goal right now. 14.7 is a real life variable. I'm getting bounced back and forth between the two because my brain can't handle this. Yes, Pug, that's what I had before, and it worked well, but this is a RAM error system where that is not the case. I can't just set a variable. That's why I'm trying to do this, so it automatically adjusts because I'm using a, not a turbo, a supercharger. I'm using a supercharger on this engine. So possibly what? Air divided by fuel is the set, and this is the, would this work? And then this will go out to the fuel. Connor, my goal is not to use someone else's tutorial. My goal is to experiment and learn and figure out why this is working the way it is. Yeah, it's understandable, but not my goal. What? Hmm. Why the fuck does the throttle just immediately skyrocket to like 2,000? I really don't see what's going on. Because air divided by the air to fuel ratio is the goal of the fuel. So instead of increasing in this situation, which it should be doing to try and keep up with the air to fuel ratio, it's decreasing. Why is it blindly decreasing here? Hmm. Air volume divided by 13.539 is the fuel goal. That's literally the ratio I'm trying to achieve here. And this is trying to balance that by changing the fuel input-output. I want to composite read that fucking the variable that's coming out of this, because whatever's coming out of this composite is not what I think it is, apparently. And it's actually really starting to frustrate me. Gee, hook these up, wouldn't it? So apparently zero is... Let me see if this math fucking works out, because this is confusing. Like, my brain is literally fried at this point, because I have no idea what the hell is going on here. Yeah, so this isn't outputting what it should be at all. Like, this is not throttling up at all. Why is that not throttling up? Do I need to, like, fuel inject this bitch? Make sure this is correct. Yeah, this is a direct fuel read. This literally makes zero sense. I'm giving it a goal, and it's not even trying to achieve it. The PID is not even trying to achieve the goal I'm giving it. Like, it it literally feels like this is not even doing basic math right now. Like, what the fuck is going on? Your goal is 13. You are only achieving 50. Why? You have so much more room to go. Why are you just giving up? And I just want to point out right now, all I've done is move the decimal place. And now it's working somewhat. My patience is gone at this point. That's why I'm so quiet. Like, literally, what? Hmm. Hmm.
fuel ratio, call it A over F, is equal to the mass of the air divided by the mass of the fuel. So we're going to talk about a mass-fuel ratio here when you're dealing with the mole ratio. And that's of air divided by of air to the number of moles of air, which will to the number of 3.7. And that's going to plus. But we're only interested in the reactants when we're talking about an air-fuel ratio. Is the molecular 2 times 14, because 14 is a molecular weight of nitrogen. There's 2 of those. 1 is the air-fuel ratio.
I'm literally watching fucking YouTube on air to fuel ratios. Because here's the problem, air to fuel ratio is based off mass. And Stormworks gives you calculation by volume. Which is probably why my math is not working, because I'm trying to use a mass calculation and a volume calculation. I don't know the weight of this in game. So I'm trying to do math to fucking Alright, my patience is gone. I'm done with this stream. I because part of the problem I'm running into is the variable that Stormworks gives you is completely irrelevant to the actual calculation for stoichiometrics. So I'm going to have to figure out what variables Stormworks uses for stoichiometrics to be able to do stoichiometrics. And I'm going to keep saying that word because I think it's fucking funny. So yeah, goodbye.